Hello everyone. Now we are going to discuss the information related with the boron family. Boron family contain boron, aluminium, gallium, indium, thallium. The boron family has the general electronic configuration NH2 NP1. That means one electron is present in p orbital. It has general oxidation state +3. Among these elements, boron is a non-metal while other elements are metals. They have shown the trend of different 10 important properties in which ionization potential from top to bottom, ionization potential goes on decreasing. While non-metallic character, again the non-metallic character is from top to bottom goes on decreasing. Again, boron is a non-metal while all other elements are the metals. Then oxidizing power, again the oxidizing power is gone from top to bottom, it is goes on decreasing. Hydration energy, electronegativity and electron affinity, all these properties at top to bottom goes on decreasing. The next, the small size of ions, their high charge and large value of their sum of first ionization energy shows the elements they have covalent in nature. Boron is always covalent and it forms the many simple compounds. At the same time, other elements like aluminium also for AlCl3, gallium also for GaCl3 and shows covalent type of bonding when they are in anhydrous conditions. There are two types, anhydrous and basis. Anhydrous condition is without water, that means there is no any absorption of atmospheric moisture. However, in solution, the large amount of hydration energy evolved results in high ionization energy and therefore all ions exist in hydrated states. Group 13 metal have the lusters in a majorly they have the silver type of lusters. Then the properties, atomic radii, abnormally there is a sudden increase in atomic radii of aluminium, and then the boron has atomic radii 90 picometer, while suddenly increased aluminium has 143 picometer, and again gallium has decreased 122 167 for indium and thallium for 170 picometer. That abnormally increase in atomic radii of aluminium we have to remember for the different competitive exams. Then ionic radii, in the whenever we are discussing the ionic radii, it shows very steady steeping or steady increasing slope, so it has no any problem. So again the electronegativity, then electronegativity, in the terms of electronegativity, boron shows 2.37 of electronegativity, while aluminium suddenly 1.50 and then steadily again increased from gallium to thallium. Then in the case of ionization potential, boron shows 80 kilojoule per mole of ionization potential, while suddenly decrease in the case of aluminium up to 577, then slowly increase in the case of gallium, again decrease in the case of indium, again increase in the case of thallium. These abnormal behavior we must remember for attempting the different questions in the different competitive exams. Then borans. When the hydrogen and boron forms the compound, generally they are called as boron. That means borans are the combination of boron and hydrogen. They have the two series BnHn plus 4 and BnHn plus 6. Whenever the borons are two in nature, they are called as diborans. When the number of on the basis of boron, number of borons, the nomenclature has been decided. When the boron atom are 4, then they are called as tetraboran. When the boron atom are 5, penta. Then when the boron atom is 6, it is hexaboran, and thus like up to decaboran. The structure of B2S6 is a multi-centered bond. Again, the question of interest is that which type of bonding in between the two borons. There are total 12 valence electrons, 6 from the hydrogen and 6 from the boron, because in outermost orbital 3 electrons are present in one boron. So 2 borons are there, 6 electrons from 2 borons as well as 6 electrons from hydrogen. Thus, there are 12 valence electrons are present in the and there is a chemical bonding takes place. Boron has 3 and hydrogen has 1. So 2 into B plus 6 into H, therefore 12 electrons are available for bonding. Each terminal BH has 2 electron bond. That means the formation of 1 electron bond, at least we require 2 electrons. That easily we can calculate, right? So there are the 4 of them, thus accumulate total 8 electrons, and these leaves a total 4 electrons to be shared between the 2 breezing hydrogen atoms and the 2 boron atoms, and therefore for this reason BHB breezing bond are formed, each consisting 2 electron forming, so called as 3-centered 2 electron bonding. So generally the boron shows 3-centered 2 electron type of bonding, meaning of it that it has 3 atoms share 2 electrons. That means there is a cooperation is there. This sometimes called as banana bonds because they are non-linear but curved, right? So among them we can consider the structure of B2S6, in which the bond between the 2 boron is PHB bond and it is 3-centered 2 electron bond, while the terminal bond between boron and hydrogen is called as 2-centered electron bond. This type of 2 types of bonding is there. In the case of B2S6, there is 2-centered electron bond and 3-centered electron bond, and that this type of bonding we have to learn in the case of to determine the Stokes number in the later version of video. Then we're coming to the last part of the important concept, that the reactions of boron halide. Boron halide react with the different intermediates to form different derivatives. When it reacts with alcohol, it will form the BOR thrice. Then whenever it reacts with water, it will boron has valency plus 3. Therefore 3 OH are attached to it. Then all these reactions, it is shown, the chart has shown different types of reactions for us. Then the important aspects of this chapter is the borazine. Most of the times this question is asked for different examinations. Then generally whenever the ammonium chloride is react with BCl3, it will give the well-known compound, that is H3N3B3Cl3, that is the chlorine atoms in boron trichloroborazine can be displayed by the hydride ion from reagents such as LiBH4. It is a reducing agent to yield borazine. When LiBH4 is react with trichloroborazine in the presence of THF, it is again gives H3B3N3H3, that means B3N3S6, and it is nothing but the borazine. When there is a compound of boron and nitrogen, generally they are called as boron nitride. The structure of 6-layer hexagonal structure of boron nitride are shown here, and that is also important as far as our examination concern. Okay, these are the all parts of all about this family. In the next video, we are coming on the points how to we can do the study of borans, we can do the study of carborane, and in the next video we are going to discuss the important concepts of high nuclear carbonyl clusters, low nuclearity carbonyl clusters, metal-metal bonding, and Wade's rule. All this information will remain in the next version. So remain along with us. Thank you.